How are we doing? Need a little more time? Yeah, for sure. Okay, Avogadro's principle, what is it? At the same temperature and pressure, whoops, equal volumes of gas contain equal numbers, yes, numbers of gas particles. So at the same temperature and pressure, equal volumes contain equal numbers of gas particles. I'm just totally making up this number, okay? So actually, let's make it 0.7 atmospheres. There we go. Oh no, that's fine. Yeah, it's fine. Whatever. So at 100 degrees Celsius and 0.7 atmospheres, 1.5 moles of oxygen gas occupies 30 liters. At the same temperature and pressure, what volume is occupied by 3 moles of hydrogen gas? have a little chat with your neighbor about that one there. You can copy the question if you want to. It's all good. Do it. Yeah. Now I've made it easier, multiple choice. So have a chit chat with your neighbors and decide what you think. Well, it doesn't matter because I don't really care about sig figs here. Okay, I don't care about sig figs. I don't care about sig figs. Honestly, sig figs when it comes to multiple choice, unless like if there's an answer that is correct and it does not have the correct number of sig figs, just go with it anyway. Okay? I'm more concerned about sig figs when you're doing the work. Yes, I will try and make sure that all the answers in the test have the correct sig figs. Here, will this make it better? Just thought it would be I just thought it would be easier if we just had like nice round numbers that just look like normal numbers. You know what I mean? No, moles are not exact. No. I don't hear anyone chatting with their neighbor. You don't need to really do anything in the way of like math on this question, like other than just like mental math. Okay, this is more of a thinking problem. Just kind of think, oh, I know that at the same temperature and pressure, equal volumes of gases contain equal numbers of particles, or you could say equal number of particles take up the same amount of space. Yes. Okay, so that's another way of saying is that equal numbers of gas particles occupy the same amount of space. Okay, those two mean the same. All right, we're going to vote on this one. And you get to vote either A, which looks like this. Okay, so you put your fingers flat on your palm and you put your thumb on the side. That is the letter A. Everyone show me an A. Okay, everyone show me a B. You put your fingers up and your thumb on your palm. That's a B. Everyone show me a C, which is pretty straightforward. You just make your hand into a C. And then D, you put your pointer finger up and all the rest of your fingers make a circle. Okay, so that's a D. And if you don't know, okay, so that's option E, I don't know. So is the answer A, B, C, or D? Or I don't know. 5, 4, 3, 2, go. Yes, it is option C because we started with 1.5 moles. How does 3 moles compare to that? It's 2 times as much, yes? And therefore, if you have 2 times as many particles, it should occupy 2 times the volume. If it was the same number of particles, it would be the same volume. Okay, so there we go. All right, what have we come up with for conversion factors? Let's grab some from all of you. Conversion. The first 4 should be easy. You've been using them forever now. What have we got? Avogadro's number. And what do we use Avogadro's number to convert between? The number of particles and the moles. When I say particles, what does that mean? What are particles? Those could be atoms or molecules or ions or formula units. Okay, and this is particles of A. You can find moles of A. All right, so that's Avogadro's number. A second conversion factor. Particle ratio. So that's the number of particles of A converted to the number of particles of B. Mole ratio. We can convert moles of A into moles of particle B. Okay. Molar mass. What is the unit of molar mass? Tell your partner, what is the unit of molar mass? Unit is grams per mole. Okay, so what can we use it to convert between? Grams of A and moles of A. Okay. All right, so those are the big 4 that we did to start with. What did we add in that we spent a lot of time on our last quiz? Molarity. Molarity. What is the unit of molarity? Yeah, it is M, but what does that stand for? It stands for, tell your partner, because a lot of people still think it's like something weird, like milliliters per gram or something. What does capital M stand for? Now, I want you to think about it this way. How do we pronounce capital M? molar. M. Okay, look, molar. Mole over liters. Mole over liters. Molar. Molar. Moles over liters. Okay? Mole over lar, except for get rid of the R. Okay? Molar. Or molarity. Molarity. Moles over larity. Okay. Hilarity, molarity. Okay. What do we use it to convert between? Moles of A and liters of A. What type of substance? What state of matter is this good for? Good only for aqueous. In other words, solutions. Okay, we learned another one last Friday. We did some practice on Monday. Do you remember what it was? Density. What is the unit of density? It is grams over liters, or some other, it could also be other mass or volume units. And what do we use it to convert between? Mass or grams? Grams of A and liters of A. This would have to be given to you in the question, unless the question is find the density. Yes, in which case you will be finding the density. And how do you find density? Density is equal to the mass over the volume. Okay, what is our seventh conversion factor? We just learned it yesterday. Molar volume. And remember, molar mass is the mass of 1 mole. What's molar volume? Volume of 1 mole. And what is the unit for molar volume? It is liters per mole, just like molar mass is grams per mole. And what is the number? At STP, molar volume is 22.4 liters per mole. And remember, you can remember this because it's as easy as 2 plus 2 equals 4. 22.4. 2 plus 2 equals 4. And the 1 goes with the mole. Okay. So what do we use that to convert between? Moles of A and liters of A. But this is only good for what type of substances? Gases at STP. Quite frankly, there are other molar volumes at other temperatures and pressures, but I'm not going to teach you all of them. Yes, because that would be ridiculous. So we now have 7 conversion factors, and you should have one of these sheets. So if you're having trouble with things, you can be like, okay, the question has given me volume, So let's actually go find that sheet so I'm not pointing at a tiny piece of paper in front of you. That's ridiculous. Here we go. Let's say I gave you volume of, let's say I gave you centimeters cubed of gold solid. Yes? And I would have to give you the density. You could then find grams. From grams, you could find moles. Could you find the volume of a solution? Would it make sense to go up here? No, because you have a solid, right? Because that would be silly. How about molar? How about going to gas? Volume of a gas, would that make sense? No, because we're dealing with a solid, right? But I could ask you to find the number of particles in there. Yes? So you can follow this little map. If you want to memorize the map, you can memorize the map, or you can just be like, I can, string things together as I wish. Okay? You should also know all of your prefixes. Okay? Because we don't have a final, we are going to review some things along the way. What are all the metric prefixes? Tell your partner. Actually, write them down. What are all the metric prefixes and their powers of 10? Mega, kilo, deci, centi, milli, micro, nano, 6, 3, 1, 2, 3, 6, 9 is for the nano. Everyone, mega, kilo, deci, centi, milli, micro, nano. 6, 3, 1, 2, 3, 6, 9 is for the nano. One more time. Mega, kilo, deci, centi, milli, micro, nano. You guys are sad. We're going to have to do it one more time after this. 6, 3, 1, 2, 3, 6. 9 is for the nano with feeling. Mega, kilo, deci, centi, milli, micro, nano. 6, 3, 1, 2, 3, 6. 9 is for the nano. Okay, now, which of these are negative? Everything from 1 up to 9. And what does that mean, right? So if I was to say I want a conversion factor between megagrams and grams. The 1 goes with the prefix, right? So that's a 1. And then what goes over beside the gram? 10 to the power of 6. So if I wanted to say I want microliters and liters, the 1 goes with the prefix and the power of 10 goes over here. This would be 10 to the -6. Okay? So you need to know those. You still need to know how to write formulas. A few people are forgetting to write their formulas. So, for example, we had sodium sulfate. And a few people were still writing NaSO4. But remember, when you write a compound, an ionic compound, you have to say, I have a positive ion and I have a negative ion, and I have to look up the charge of that negative ion, so the formula will be Na2SO4. And I'm not going to give you all of them where I write out the name and you have to do the formula like on the test, but there will be 1 or 2 so that I make sure that you remember them. Okay, this is in place of a final. Yes? We're just throwing in a few things from earlier units. All right, so your homework right now that you're going to work on. Okay, all these 3 at the bottom though, those are all enriched stuff. And if you haven't done these enriched things, do those before you do those. Yes? If you're like, I have converted and I am done with converting, these can be a little more fun. Okay? So want to redo a quiz, we can redo a quiz. I do have the molarity quiz. I've got a redo version of it. And it should say B, because apparently I forgot to do that. There we go. There we go. The other one, yes. Yes, 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 absolutely. That one is that one. There is not, but I could make one. Okay. There is no requiz C for these, but if